Hi, my name is Cassandra Ferana Sumer and my student ID is 2024401262.
Hello, my name is Angelina Ninja. My student ID is 2024218296.
Hi, my name is Charinga Bulawai and my student's ID is 20244251222.
My name is Chalimba Daniel. My student ID is 2024419058.
What is conventional hollow concrete bricks? Conventional hollow concrete bricks relies heavily on the natural aggregates, which in turn increases the dead load and causing the depletion of the natural resources. Thus, to promote sustainable construction practices, this project investigates the partial replacement of natural aggregates using an agricultural products that is kernel shell. Unlike conventional natural aggregates or non-porous synthetic material, kernel shell exhibits a rough, irregular surface texture and a unique cellular structure that leads to higher water absorption. However, due to its porous structure that has high water absorption that could affect the workability of the design, proper mix design is necessary to ensure the optimal structural stiffness. Therefore, this could prevent the premature drying shrinkage and ensure a strong interlocking bond between the kernel shell particles and the cement paste.
Before we move to the procedure, we will show you the apparatus that we use for this project. First, the weighing balance. Second, graduated cylinder, cement bucket and mixing pan, trowel, our formwork mold, tamping rod, water curing tank, and finally, compression testing machine. The first thing that we do is the palm kernel shell is sieved and we wash it with hot water to remove any palm oil that coating the shell. And we dry the shell to drain all the remaining water. After that, we prepare our formwork mold that satisfies our hollow brick size. It has the standard required dimension of 220mm long, 100mm wide, and 70mm thick. We apply a thin layer of oil inside the mold so the concrete will not stick to the walls. Then we will move to the mixing concrete. First, we will weigh sand, cement, aggregate, and our sieved palm kernel shell using our weighing balance. Next, we mix it together in the mixing pan and add water from our graduated cylinder. We stir it well until it is uniform, and then we put it in our mold. We use the tamping rod to compact the mix layer by layer. We use the rod to make sure we remove all air bubbles so the brick becomes solid and strong. After that, we will let it dry for 24 hours. After it is dry, we will open the mold and let it sit into the water tank for 7 days. After 7 days, we will take the bricks out of the water tank and we wipe them dry and measure them one last time to check their dimension and weight. Now we will put the bricks in the machine and run the machine and we will get the result. And watch the load increase until the bricks cracks and fails. The machine automatically record the maximum load. Moving on to our result and summary of finding. This is the result that we get from the monitor. This table shows the mechanical properties for our sustainable bricks, which were all tested in horizontal orientation. Overall, our testing yielded a calculated average ultimate failure load of 40.02 kN and an average compressive strength of 2.6 megapascal for this batch of hollow bricks. Looking at our result, we noticed a significant difference in strength across our three samples. While brick 1 and brick 2 have fell at around 1.7 to 1.8 megapascal. Brick 3 achieved a much higher strength of 4.3 megapascal. This variation is likely due to the manual compaction process during the fabrication. Better tamping on brick 3 successfully removed internal air void, resulting in a denser and stronger hollow brick structure. From a student's perspective, implementing this mini project has several major advantages. In my opinion, the first advantage is bridging theory and practice. It allows us to take the structural and material theory we learn in the classroom and apply them directly to hands-on laboratory works.
So my point of view of sustainability awareness, it shifted our mindset towards green engineering, showing us exactly how we can reduce environmental impact by turning agricultural waste into useful building materials.
As for the aspect of the problem-solving skill, we have learned to how to analyze the unexpected data variables like the strength jump in brick tree, which built our critical thinking skills.
For our teamwork, we coordinate our batching, manage the 7 days curing timeline, and testing together taught us the essential project management skills.